Whew, that was some hard practice today. I'm exhausted.
Blaziken.
Pig-happy. Me too. And hungry. Brock's going to make dinner like always. Shouldn't we do something too?
Yeah, but what?
Well, Brock's the best cook, so how about we make something to drink?
That's a great idea. Let's see what we've got.
Let me think about what Brock likes. How about grape juice? Is there any grape juice?
I don't think so. Hey!
We have it?
No, but I've just had a brilliant idea. We don't have grape juice, but we do have grape jelly. Why don't we mix that together with water to make grape juice?
Okay, that is a pretty good idea. Let's try.
Here's some water.
And here's the grape jelly.
Okay, now I'll just stir this together.
It's not stirring together. Stir harder.
I'm trying. You try.
That doesn't look so good.
Let me try it.
Does it taste grapey?
No, it tastes like chunky water. Gross.
Let's add some more.
I wonder if there's something else we need to add to it to make it work.
How about calling Siara? She might have some ideas. Scientists know a lot about mixing and making stuff.
Good idea.
Hey, how's it going? What's this? Brock's not in the kitchen?
We're trying to make a surprise for him.
But it's not working out too well. We wanted to make grape juice by mixing together some grape jelly and water.
But instead of grape juice, we're just getting chunky grape water.
Oh, well that doesn't sound too delicious, does it? You've got a mixture when what you want is a solution.
What's the difference?
A mixture is any combination of materials that are mixed together. Like when you toss together a salad, that's a mixture. Mixtures are held together by physical means. That means everything in a mixture is really just sitting next to each other. Nothing happens to the materials when you mix them together. Their physical properties don't change. For example, look at those salad ingredients. You have lettuce, tomatoes, and carrots. Now mix them together.
Okay.
Take a look. Everything is mixed together, but the lettuce is still lettuce, the tomatoes are still tomatoes, and the carrots are still carrots. If you took them all out of the bowl again, they'd be the same as they were before they started.
So you can separate all the ingredients in a mixture, and they're still the same as they were before they were mixed.
That's right. Mix it together, take it apart. It's all the same. Cement is another good example. Cement comes in a powder form. It's made up of all kinds of ground-up rock and sand. When water is added to it, the mixture dries into the form in which it's poured. But you can smash a piece of cement and it will break up into small pieces of the same rock you started with.
Cool!
And of course, your grape jelly water is a mixture. As you discovered, mixtures don't make very good drinks because the ingredients never really blend together. They might look mixed for a little while, but usually one ingredient is heavier than the other. They separate and some sink to the bottom.
Yep, that's our grape jelly water.
Now a solution is a mixture where the substances are completely mixed together. Remember, all substances are made up of tiny, tiny particles called atoms. When one type of atom bonds with one or more other kinds of atoms, they make up molecules. Each substance in a solution is made up of its own group of molecules. When the substances in the solution are mixed together, each group of molecules makes room for the others, so that all the molecules are evenly distributed throughout the solution. In a mixture, there might be some molecules here, some molecules there. In a solution, they are all spread out the same way.
So what's the way to tell if something is a mixture or a solution?
Often you can see the difference. Try this. Fill 2 glasses of water. That's what we call the solvent, the substance that's going to do the dissolving. Scoop 2 spoonfuls of salt into 1 glass. Now see that plant over there? Scoop 2 spoonfuls of dirt from the plant into the other glass. The dirt and salt are the solutes. They're the substances we are mixing into the solvent and are hoping will dissolve. Now stir your solutes into your solvent. Stop. Wait a few seconds.
Yuck!
Double yuck.
When you stir the solvent and solute together, the molecules of the solvent begin to shift out of the way. They make room for the molecules of the solute. The molecules of the solvent, don't forget, the water is the solvent, keep moving until the molecules of the solute, that's the salt, have enough space. The molecules in the solute break up into smaller pieces. They dissolve so they can fit into the space made by the solvent. The molecules of dirt don't break up into smaller pieces. There isn't room for them. They just sink to the bottom.
So when the molecules in the solute break up to dissolve, does that mean they're changing into something else?
Nope. Like the molecules in a regular mixture, they still are made up of the same stuff. The lettuce molecules stayed the same whether they were mixed with the tomatoes and carrots or were left by themselves. The molecules in a solution are still the same molecules. They just make themselves smaller so they can all spread out.
Can you make a solution out of anything?
You can try. You can mix liquids with a gas. Soda's a good example of that. The liquid of the soda is mixed with the gas carbon dioxide, which gives the soda its fizz. There are solid solutions, but they usually start out as a mixture of liquids, or a mixture of a solid in a liquid. A change in temperature or pressure can turn a liquid solution into a solid solution. You can melt two metals, such as copper and silver, mix them together, and then let them cool into a solid. That's a solution.
Can you take a solution apart?
Yes, but you have to work a little harder than with the regular mixtures. For starters, you can put too much solute into the solvent. Every solvent has a point at which it can no longer make room for all the molecules of the solute. That's called the saturation point. When the saturation point is reached, the extra solute separates from the solvent.
So if I put a lot more salt in a glass of water, some of it would sink to the bottom?
Exactly. You can also separate a mixture by changing temperature or pressure. For example, when you open a can of soda, you're dropping the amount of pressure that was holding the carbon dioxide and liquid together. The carbon dioxide fizzes and escapes into the air. That's why soda goes flat after a while.
I always wondered why that happened. Now I know the solution.
Ha, not funny.
You can also separate a solution through a change in temperature. If you boiled a solution of salt and water, the water would boil off into vapor, and there would be salt left in the bottom of your glass. Evaporation can also take apart a solution. If you left the liquid solution out for a while, the water and the liquid would evaporate off after a while, leaving nothing but solids.
So mixtures are anything mixed together. They can be separated, like by hand.
Yes, mixtures can be physically separated.
And solutions are where the molecules are evenly distributed and you can't just take them apart. You have to do something like change temperature or pressure or add too much solute to separate the mixed up molecules, right?
Right. Now let's test that out. I have 3 different food colorings here, red, blue, yellow. Let me squeeze 2 drops of each onto this piece of wax paper here and mix them together. Do you think this is a mixture or a solution?
I think it's a solution. I mean, it looks like all the colors are spread out the same, right?
Let's find out by separating it. Let's grab a coffee filter here and drip some drops of our black color on it. Now let's let them dry.
They look dry to me.
Okay, I'm going to put a little water on my finger and wet each dot and give the water some time to work.
Wow, look!
So what do you think now? Mixture or solution? Click on your answer. Awesome! The colors we originally used were easily separated with physical means. They kept all their original properties. Let's try something else. Pour 2 spoonfuls of sugar into your glass of water. Stir them together. Look at the sugar. What happens to it when you mix it in the water? Click on the right answer. Cool. The sugar dissolves or breaks into smaller molecules when you mix it in the water. Look at the glass. Is that a mixture or solution? Click on the right answer. Excellent! The sugar molecules are evenly distributed throughout the water. That's a solution. Which is the solvent in this solution? Click on the correct answer. Excellent! The solvent is the substance that has something mixed into it. The sugar is the solute. Now let's test this solution out. Take a straw and press it all the way to the bottom of the glass. Leave a little space so you can take a sip. Try it. How does it taste?
Sweet!
Just like it should. After all, it's sugar water. Now hold the straw midway up the glass and take another sip. Now one more try. Put the end of the straw near the surface of the water and take a sip. Okay, now at which spot in the glass do you think the water was sweetest? Click on the correct answer. Awesome! Since this is a solution, the sugar molecules are distributed evenly throughout the water. It tastes the same no matter where you sip. You did a great job with those experiments. Let's see if you can identify more about mixtures and solutions. Look at the bowl of vegetable soup. Is it a mixture or solution? Click on the correct answer. Cool! Look at the jar of water from the ocean. Is it a mixture or solution? Click on the correct answer. Excellent! Which is the solute in the sample of ocean water? Click on the correct answer. Awesome! Look at the chocolate chip ice cream cone. Is the chocolate chip ice cream a mixture or a solution? Click on the correct answer. Excellent! Look at the plate of macaroni and cheese. Is it a mixture or a solution? Click on the correct answer. Awesome! Look at the can of soda. Is the soda a mixture or a solution? Click on the correct answer. Awesome! Which is the solute? Click on the correct answer. Excellent! How does opening the can separate the solution? Click on the correct answer. Awesome! Look at the glass of lemonade. Is it a mixture or solution? Click on the correct answer. Cool! What would be left if you boiled the lemonade for a long time? Click on the correct answer. Awesome! So, do you know now why your grape jelly juice didn't work?
Absolutely. The grape jelly solute doesn't dissolve into the water solvent.
That's very impressive, May. So what are you going to make instead?
I know. How about a solution like lemonade? We have water, we have lemons, and we have sugar. And once we squeeze out the lemon juice, we know they'll all mix together.
That sounds like a great solution. I love lemonade.
So do I, but I've had enough solution jokes for one day. Good luck.
Bye, Siara. Let's get to work.
Think about it. The colors are just about the same as they were when they started. We separated them using physical means. Try again. Think about it. The colors are just about the same as they were when they started. We separated them using physical means. Try again. The colors we originally used were easily separated with physical means. They kept all their original properties. It looks like the sugar is breaking up into smaller molecules and spreading out in the water, doesn't it? Try again. Remember, a solution is a mixture where one substance is evenly distributed throughout the other. Try again. Remember, the solvent is the substance that is having something mixed into it. Try again. Think about it. This is a solution, so the sugar molecules are distributed evenly throughout the water. Try again. Try again. Here's what we're looking for.